Dear students, a good day to all of you. So, in your previous practical lab, I have shown you experiment number 1 as preparation of standard oxalic acid, primary standard oxalic acid solution. So, now the question is, what is the requirement of preparation of a primary standard solution? This is basically required to standardize a secondary standard solution. Now, what is the difference between primary standard and secondary standard? If I can say in a very simple way, a primary standard solution is much more stable in normal environment, like normal room temperature and pressure. It is highly stable. That means a primary standard, so concentration of a primary standard solution is fixed. It will not be changed. But if you prepare a secondary standard solution, the strength of the solution will be changed automatically due to the effect of normal room temperature and pressure. So now what we will do, we have to standardize our secondary standard solution to determine the exact strength. Exact strength, that means at the time of your experiment, what is the actual strength of your solution. So for this, we have to take a reference primary standard solution to identify the secondary standard strength of a secondary standard solution. And this is the process called standardization, which we will use to determine the exact strength of secondary standard solution. So exactly today's experiment, that is experiment number 2, is standardization of NaOH. Previous experiment number 1 was preparation of oxalic acid, primary standard oxalic acid solution. So if we want to titrate the oxalic acid, we have to use a base. So the base is NaOH. So today's experiment will be standardization of NaOH solution using standard oxalic acid solution which you have already prepared in the experiment number 1. Okay. So, and obviously we have to use, since this is an acid-base titration, so we have to use phenolphthalein as an indicator. We can take methyl orange also, but you have to identify that which indicator is required for which titration. This is based on basically the pH of the solution. Let me just show you the practical. I am not going very deep to the theoretical part as it will be discussed by your faculty. So I will just show you how you will perform a standardization of a secondary standard solution. The secondary standard solution, that is NaOH solution, will be supplied to you. So you have to just determine the or calculate the actual strength of this NaOH using titration. So the strength of the NaOH will be unknown for you for this experiment. But the actual strength of oxalic acid, which you have already find out in the experiment number 1, it will be used to calculate the actual strength of NaOH. How you will calculate? Everything is written on the manual. You will get the manual also in PDF form. So don't worry about that. Whenever, I'll suggest you that whenever you are watching these video lectures or any kind of practical videos, just follow the manual, follow the procedure side by side so that you can relate with the experiment. So in this case, what we will do basically, a basic formula you have already learned in your higher secondary, that V1S1 equal to V2S2, right? This portion you can take for oxalic acid, which is oxalic acid. This is your known part. And this portion you can take for NaOH, which is unknown part. How it is known? It is unknown. If you see the experimental procedure, you will find that a specific volume of oxalic acid you have to take in, which is written in your manual, that is 25 ml. Right? And the specific strength which is already calculated in your experiment 1, let us assume it is accurate n by 10, that is 0.1 normal or 0.1 normal. So this is your known part, and in case of your unknown part, that is NaOH, this V2 you will get from the burette reading. You will get after titration, whenever your experiment is completed, you will get the burette reading, which will be your V2. So this is you have to actually find out. This is you will actually get from the burette reading. So it is also, you can consider known to you, because you know after finishing your titration what is the burette reading or how much volume is consumed by NaOH to neutralize the 25 ml oxalic acid. Clear? Now you have to calculate this S2. This you have to calculate. So in this way the whole experiment will be done. So again I am saying that whenever you are studying these video lectures, please refer with your manual also to better understanding, because everything is written in the manual. Also I will request you, whenever you are coming to the lab, before coming to the lab you just go through your manual, so that everything you can understand whenever we will physically do the experiment. Here is your basic setup for the standardization of NaOH. So you can see that here is your standard NaOH solution, which I have already told you that you will be provided in the lab to determine the strength of the solution. So here is your NaOH, and this is your phenolphthalein indicator, which you need to be used in your titration, and this is your oxalic acid. Primary standard oxalic acid, which you have already prepared in your experiment number 1. So today this solution will be used to standardize the NaOH. Now what you have to do, first of all, you have to keep ready your burette with the titrant. So the secondary standard solution, that is NaOH, you have to fill into this burette solution. First of all, burette knob is closed. Now I will transfer very carefully. Open the knob and fill this part first of all, so that there should be no air or there should be no bubble inside the burette. See, bubble is coming out. You have to do this repeatedly until or unless the complete air is removed. This transfer and return. After removing the air or any bubble, now you have to make up 0 of the burette. So your burette is ready. Now just clamp your burette. NaOH is kept aside. Now you have to prepare your sample solution. So for this you have to always remember that the standard solution you have to pipette out using the pipette for titration. You can see that this is a clean pipette. Now I just always remember that whenever you are handling the glassware, just don't play with it. Just simply you have to use it and you have to keep it aside. We have taken all the last drop. Now after taking the sample solution, you have to add not much, just 1 drop of indicator. See, the indicator is generally used to indicate the neutralization point through color change. So 1 drop is sufficient for any kind of titration. Whenever you are using indicator, 1 drop is sufficient. So don't add much more indicator, otherwise it will be just a waste, nothing else. Now you have to start the titration. I have already shown you just how to control the burette knob. So we have to start with one thing. You have to always remember, whenever you are titrating, below the conical flask you can place a white paper, as you see in the video. This paper is basically we have used to view the prominent color. The color changes should be it will be prominent because the reflection will be better. So the color change will be easily detectable to your eye.
Now you can see that whenever a drop is adding, a pink color is occurring, but after stirring it is vanish. So until or unless a faint pink color is observed, as you have used phenolphthalein as an indicator, so the end point of the titration will be pink color, faint pink color means light pink color. So until or unless a light pink color is observed and the color should be stable for at least 10 seconds, at that point your titration will be over. So until or unless a pink color is observed, you have to continue add drop by drop from the burette. Always remember that whenever you are titrating using burette, your concentration should be inside the solution, not inside in the burette reading. Always remember that, because if you concentrate in the burette reading, suddenly you will see that your color has been already appeared and you have added some extra amount, and it will make your calculation error. So be careful with that. Your observation should be always in the solution. Here, see, pink color is already appeared, but color does not persist. So you have to add carefully drop by drop. Now you see that the color is observed. See, a faint pink color is already observed and the color persists for more than 10 seconds. So your titration is now over here. That is, neutralization of acid and bases has been occurred. Now if you see the burette reading, I'll show you. See the burette reading. What is the burette reading? 14 point. Considering the lower meniscus, 14.8. You can see here 14.8. Okay. So this is your V2, which I have already told you in the demonstration. So now you know V1, S1 and V2, you can easily calculate S2. So this is, after finishing your experiment, you have to note down your reading. So the table form is already given in the manual. So that table you have to maintain a rough copy, and in which day you will perform your experiment, you have to note it down, all the readings, all the procedure, everything, calculation, your equation and everything you have to write down. And after that, after noting your reading, you have to calculate your rough copy. So this reading I have already shown you one reading, that is first reading. So in this way you have to repeat this same experiment for 3 concordant value, that is first set, second set and third set. 3 similar reading you have to take, and then you have to note down, and you have to make an average. The average value will be concordant value. On the basis of the concordant value, you have to finally calculate your called strength. So thank you all.